Okay, let's rattle through some more examples of integration by parts. Let's say we have the integral of x squared e to the x dx. U substitution will do nothing here. We just don't know this off the top of our heads. We use U substitution. Again, no logarithms, no inverse trig, but we do have a polynomial x squared. So if U is x squared, the whole rest dv is e to the x dx. We take the differential of u, du is 2x dx, and v is the integral of this, which is pretty easy. It's just e to the x. So I'll write this just one more time. Integral of u dv equals uv minus integral of v du. Here is your u, here is your dv, so we in fact have that. Let's isolate this from what we're actually doing. And so this whole thing, integral of x squared e to the x dx, is uv x squared e to the x minus the integral of v du, which I'll just mash all these together. 2x dx times e to the x. I'm going to put the 2 out front, and I'll say x e to the x dx. We don't know how to solve this again. We have to use another round of u substitution just on this little bit over here. We say u is x, dv is e to the x, du is just dx, v is, this is e to the x dx, e to the x. So what do we have? We keep the x squared e to the x alone, minus 2. That whole integral is going to become uv minus integral of v du. So it becomes x e to the x minus the integral of e to the x dx. And if you notice, this is why setting u equal to a polynomial is nice. You set u equal to x squared, you go through the process, you end up with an x. You go through the process, you end up with a nothing, a constant. And it whittles away things. It whittles away polynomials. So what do we have? We have x squared e to the x minus, multiply this out, 2x e to the x minus plus 2 integral of e to the x dx. And I know what that is. That's just e to the x squared e to the x minus 2x e to the x plus 2 e to the x plus c. And the question is its derivative really x squared e to the x? This is the last one I will check. What the heck, I can just write right over this. The derivative of that whole thing is product rule, 2x times the e to the x left alone plus the x squared times the e to the x. That's the derivative of the e to the x. Here, derivative of 2x is just 2, e to the x left alone, minus 2x left alone, derivative of the e to the x, plus the derivative of 2e to the x is 2e to the x, and the derivative of c is 0. And when you cancel out, when you write in red, what have we got? 2e to the x cancels with 2e to the x, minus 2x e to the x cancels with this. We are left with x squared e to the x, which is what we wanted.